Hello students. So let's solve some physics numericals. Okay. A metal has a threshold wavelength of 6000 angstrom. You have to calculate threshold frequency and work function. Okay. So we have the energy of the incident radiation is given by h nu equal to kinetic energy, which is maximum, plus the work function. Correct? How the work function is written? H nu naught. Okay. This is your threshold frequency. Now here we are given threshold wavelength. That is, we are given lambda naught, 6000 angstrom. So we have to convert it to meters. So 6000 into 10 raised to minus 10 meter. Okay. Now how you can write the work function? So the work function, I'll write it as phi naught. Okay. Or you can write W naught. So H value we know. How we write frequency in terms of wavelength? We know that lambda is equal to C upon mu, right? So we can write this as C upon lambda now. Okay. Now you have to substitute values. So 6000 into H we know that is Planck's constant 6.63 into 10 raised to minus 34 into C is 3 speed of light. 3 into 10 raised to 8 upon lambda naught is 6000 into 10 raised to minus 10. Okay, so we have to solve this. Okay, I solved the B question, that is work function. Okay, so I will take this 6.63 into 3 and I'll write here 6. Okay, 10 raised to minus 34 plus 8. This will go in the numerator and will become plus 10. Then this 3 zeros. So 10 raised to 3 here in the denominator. In the numerator it becomes minus 3. Okay. This is 3 2s. So I'll get around 2 3s into 10 raised to minus 34, 18, 18 and minus 37. Okay. So it will be around 19 minus 19. And this is in joules. Okay, but we have to find work function in electron volt. Okay, so we have to multiply, no, not multiply, we have to divide by 1.6 into 10 raised to minus 19. Okay, so 3.315 equal to upon 1.6. So I can write here 3.315 divided by 1.6. Okay, I'll remove the points. So I have to multiply here by 10 raised to 3 and this is 10. Okay, 10 raised to 1. So dividing you'll get 16. 7. 207.1 into 10 raised to 1 minus 3 minus 2. So 2.07. This is in electron volt. Okay. This is our work function and we have to find threshold frequency. So to find threshold frequency, you have to make use of our thing, that is C upon lambda naught. Okay. C is 3 into 10 raised to 8 and this was 6000 into 10 raised to minus 10. So 3 by 6 into 10 raised to 8 plus 10 minus 3, half. So 0.5 into 10 raised to 18 minus 3, so 50. This is our threshold frequency. Okay, frequency means it's in hertz. Next question, you have to calculate the equivalent resistance. Okay, so our circuit starts from A to B. So it starts at A and finishes at B. So we have to calculate the resistance in between these 2 points. So you can start with these 2 points, these 2 resistances. Okay, or yeah, you have to start from here. Okay, so starting from here, these 2 resistances are in parallel, correct? So this will be, so I'll draw it. So it will be, this remains same. So you'll get like this. Okay, these 2 are in parallel, so I'll write it RP. So this RP comes to be 5 ohm. This is 1 upon 5. So RP is 5 ohm. Okay. So this is your 5 ohm resistance. This is 10, this is 10 and this is 10. Okay. Next, now these 2 are in series. Okay. So next, so like this. Series means you have to simply add them. So this becomes 15. Okay. Now next you have to take these 2 resistances, that is these 2 are in parallel, correct? So last you'll get like this. So parallel you have to calculate 1 upon 10 plus 1 upon 15. So this is 15 plus 10, 25 upon 150. Okay. 1 by 6. So the resistance is 6 ohm. And final, the resistances are in series. So you have to add them. So the final value is 16 ohm. Okay. Next question. A radiation of energy 7.2 electron volt falls on a metal surface having work function 3.2 electron volt. Find kinetic energy in joules. So radiation, incident radiation energy is given. Okay. So we have to find the kinetic energy in joules. So we have to convert this. To convert it, we have to multiply by 1.6 into 10 raised to minus 19. Okay. What about work function? Work function is h nu naught. So this is also given. Converting it joules. Okay. So you have to find the maximum kinetic energy. So how we write incident radiation energy is equal to kinetic energy plus the work function, correct? So our kinetic energy is minus this. So we have 7.2 minus 3.2 and I'll take this 1.6 common. Okay, so we'll get 4 into 1.6 into 10 raised to minus 19 joules. So 4 into 16, 16 for the 64. This will be 6.4 into 10 raised to minus 19 joules. Okay. Next question. We have to calculate the equivalent resistance between points A and B. Okay. So between these 2 points, we have to calculate the resistance. So you have to keep this resistance as it is. Okay. Just solve all these resistances. So we can start from this part, that is ADC. So these two resistances are in series, correct? Like this. Then the resistance which we get by adding them will be in parallel with this resistance 10. Okay, I will just draw this. So A and B you have to keep fixed. So you will get like this. Okay, if they are in series you can directly add them. So this becomes 10. Next, these two are in parallel. So parallel 1 upon 10 plus 1 upon 10, 1 upon Rp, 2 upon 10. So you'll get this Rp as 5. Okay. So next, so here I'm getting 5. Correct. Now these two resistances are in series. Correct. Like this they have charged. So series means you can directly add them. So last you will get like this. So 5, 5, 10. So last we have the resistances in parallel. Again you will get 5. Correct. So the last resistances, 5. Total resistance, equivalent resistances 5 ohm. Okay.